Hello, everyone. I hope that you are doing well, and whenever you are in good health and happy. So I am here to give you a lecture from the statistical research method for your module in economics and finance. So actually, I do believe that you already went through hypothesis, and you know what is hypothesis, right? So now we're gonna look at the fundamental of hypothesis testing and one sample test. So let's get started. What is the objective of this lecture? Actually, so based on your understanding of hypotheses, we're gonna just do a quick recap of hypotheses, and then we're gonna look at different problems to see how we can solve this kind of problem based on mean or proportion. Then we're gonna look at different procedures based on different assumptions to evaluate the consequences from the different tests. And then based on that, we might reject the hypothesis, the null hypothesis, or accept it. Then we're gonna look at the different ethical issues. So, yeah. So I think you saw this diagram in previous lecture. What is about actually telling you that first of all, we need to apply hypotheses to establish two hypotheses, null and alternative. So then we need to do a test to determine whenever and whether a test is statistically significant or not. Then we need to be able to find different type of error type 1 and 2. So, and then after just collecting your data and sampling, then we need to analyze data to be able to understand it and find a pattern between different structures. So at the end, we're gonna go to the conclusion and say, okay, so this problem is statistically significant or not, to be able to solve the business problem, actually to determine the business implication. So first of all, we're gonna look at the p-value. So p-value and alpha are two main concepts in hypothesis testing. So actually, another way to reach a statistical conclusion in hypothesis testing problem is by using the p-value, sometimes referred as observed significance level. The p-value is growing in importance with the increasing use of statistical computer packages for testing statistics. So we call that if we obtain a statistical test which is more or less than or equal to a specific value, which is 0.5, then we're gonna accept the null hypothesis or we're gonna reject it. So based on that, we're gonna look at the smallest value of alpha, which was known as standard error, for which hypothesis, the null hypothesis, can be rejected. So yeah, now let's go and based on a given p-value, so we're gonna find out the what is the result for a statistical test. Actually, what we're gonna do in here, I'm gonna walk you through a different strategy, instead of the previous one. So the probability of getting a test statistic, at least as extreme as the observed test statistic, which is computed from the data, should be under assumption that the null hypothesis is true or false. If is extreme, then it's gonna be null hypothesis gonna be true. Actually, every statistical computer problem yields this probability or p-value for being able to cope with different problems. So p-value defines the smallest value of alpha, as we mentioned earlier. So if p-value less than alpha, then we're going to reject null hypothesis. And if p-value greater or equal to alpha, then we are not going to reject the null hypothesis, and then we're going to accept it. So here you can see one example that is telling you that we have a sample mean of 2.84, and then we want to see if the true mean is the population is equal to population mean of 3. So what we have sample mean of 2.84, which is translated to a z-score of z equals to minus 2.0, which you can find this value easily from the z table. Okay. So as you can see, we have here two-tailed tests. We have half of alpha in here and half in here, which the alpha is all of this area. And we call this the critical value, right? So, but what you need to see, so what you need to see is that the alpha for 0.05, half of that for one tail gonna be 0.025, and then in the right hand side the same as well. So we want to see that the probability of the z score less than -2 or greater. We are looking for the extremes. So actually, when we want to find the p-value, one different thing with the confidence interval that you need to be careful in hypothesis testing is about when you have two-tailed tests, then you need to add both extreme condition probability of them. So I mean that it's not just enough that you say, okay, so if I calculate this, then this is gonna be my probability. No. So you need to be able to find the p-value by adding both sides. So the smallest value of alpha in both tails. So actually, I'm gonna tell you one more time for a two-tailed test. So I'm gonna recall that we split alpha to determine the critical value of the test statistic, right? So with the p-value, the probability of getting a test statistic at least as extreme as the observed value is computed. So actually the p-value is then compared to half of alpha. So this p-value gonna be compared with half of alpha, not 0.05 full. So then we need to be able from the comparison to determine the statistical significance. So actually I need to just emphasize this, that the business researcher like you should be able to find a test which is statistically significant, and you need to report the p-value in different situations, which is very important in your subject. So if we want to compare the p-value with the standard error or alpha, we need to be able to go to the conclusion and conclude that we're gonna accept or reject the null hypothesis. So by using the standard normal table, so you find the probabilities, the z-value, and then probability of the extreme value. Then by using this information, you can say that the value, the p-value, is either less or equal or greater than alpha. So in here, based on two probability that we find in each two tails, these two values, sum of these two, which is this number, 0.0456, we find out that this probability is less than alpha. So then we're gonna reject the null hypothesis. Why we compare this value by full alpha without splitting alpha? So because this probability is based on two tails value, right? Okay, let's continue. So we want to see what is the relationship between confidence interval and hypothesis testing to finding a test which is statistically significant. So let's look at this example. For sample mean of 2.84 and a standard deviation of 0.8 and sample size of 100, then we're gonna have 95% confidence interval. So they are given. So we do have we do have a standard deviation known. Then we're gonna use the z-score. So based on the 95% confidence interval, then we do have a confidence level of 0.95, which should be subtracted by 1, and then we're gonna have alpha of 0.05, and then we're gonna have this z-value for that alpha. So based on this, then we're gonna find the critical value. This is the critical value, and then we don't have a error in here, a standard error, and then we're gonna add, and then we're gonna add and then subtract it by the sample mean to be able to find the interval, the confidence interval. Then at this stage, we are able to say that how confident we are in which interval to be able to say that this sample mean representing the mean of the population. So here we go to conclusion that since this interval does not contain the hypothesized mean, we reject the null hypothesis at alpha 0.05. Why? Because those values you cannot find tree between these two values, right? So is somewhere after this upper bound. So then we're gonna reject the null hypothesis. So in confidence interval, you need to be able, if you're looking at the sample mean, you need to find the actual population mean within this interval. Otherwise, you're gonna reject the null hypothesis. So let's look at the next concept, one-tailed test. So in hypothesis testing and to finding the actual p-value and then to be able to reject or accept the hypothesis, we need to be able to find the probability of the p-value that is less or greater than alpha, to be able to say that is gonna accept or reject the null hypothesis. So when we do reject the null hypothesis, then we're gonna accept the alternative hypothesis, right? So, and they are kind of comparing to each other, they don't have any intersection. If you look at this, there is nothing in this interval that we can find in the other. So we call this type of test one-tailed test. So this is a lower tail test, since the alternative hypothesis is focused on the lower tails below the mean of 3, because we are just considering one side of the curve. If you look at this, part, so you can see the alternate hypothesis is just looking at the one side, which is left side of the normal curve. How about this one? So if we change it to the other values, even null hypothesis is less than, is not like the previous greater and equal, and alternate hypothesis is greater, then we do have the upper tail test. Still lower tail and upper tail, they are both one-tail tests, because we are considering one side of the normal curve. So here you can see that is just using the graph to visualize. As I said, this is the left-hand side, which is less than 3. So this we call it lower tail or one-tail test. Let's look at the next one. Here you see that is greater, which is in the right-hand side of the normal curve. Do we reject it or accept it? So if you look at the previous one, so can we reject or accept this? Is there this part is accepting this value or not. So we need to find out that we do have a population mean of 3, then we do not reject null hypothesis, because actually the value of the population means is within this interval. Then we cannot reject the null hypothesis, right? So the same terminology in the next one, because still we do have 3 as a mean of population within the null hypothesis interval. So here you can see that the upper tail z-test when alpha is known. So there is another example. If you want, you can look at that. So a phone industry manager thinks that the customer monthly cell phone bill have increased and now average over $52 per month. The company wishes to test this claim. Assume a standard deviation is equal to 10 and is known. When a standard deviation or sigma is known, then we can use the z-score and z-statistic. So how we can figure out this? So we can look at this example. Let's read it again. So we say something, the bills, something have increased and now average over 52 per month. Is there, whatever is the problem giving us is given in the problem, and this is based on our assumption, so we can assume as an alternative hypothesis. In here, we do have this value, $52, and we do have some condition saying the average over not equal. So we find out that quickly, this is one tail. So when we say over, we mean greater. Then we can say whatever, we can say the average or population mean greater than 52 is our assumption or alternative hypothesis. Then whatever is not in this interval gonna be in null hypothesis. So based on the problem, you're gonna find out the exact value of the exact interval of alternative hypothesis, and then you find out that is not equal, it's just over, which is one tail test, and is greater than is upper tail, right? So you can use this scenario for the similar questions. So let's look at this. We have another assumption in here. Alpha is given 0.010. So then we do have just one tail. We don't need to split alpha. We do have a whole alpha is right-hand side of the normal curve. And then we're gonna say that either we reject or accept the null hypothesis. What we can do, we need to look at the value, the interval in here. We see that the average is covering 52. Then we say we are not able to reject null hypothesis and we have to accept it. So in one tail test, the critical value can be obtained based on the standardized normal distribution table, right? So you can find it from here, and then you would be able to say that what is the critical value, and we do have a confidence level of 0.90, and then we do have this value which shows the probability of this part. Then what we're gonna have, based on the z-score, we can calculate. So here is another example. So we do have another example in here, which is the standard deviation is 10 and is known. We have sample size of 64, and we do have a sample mean of 53.1, right? So we know that the alpha is known. We are able to use the z statistic, and we do have a sample size, and then we know that the sample mean is known. So we need to just replace the values 52 as the mean or average of population, and then sample mean, and then standard error based on the sigma, and then n, root of n. And then we do have the z value of 0.88. So once we got to this stage and we find the z value, so we find the probability of this, then we say we do not reject null hypothesis. Why? Because this value is less than critical value. So yeah, so you need to be able to understand this easily. So what is these two different? They are both on z, right? But the first one is just obtained based on the alpha. First one is obtained, first critical value is obtained based on the z-score, is based on the alpha. But the second one is based on what is the problem, is in the problem given. So you need to find 2z, and we need to compare that. And if the actual z is less or equal to the critical value, which is based on alpha or confidence interval, then we need to say that this value is not in here. So there is, we can interpret at the end that there is not sufficient evidence that the mean bill is over 52. That is the conclusion at the end that we need to come across. So how about the p-value? If we want to calculate the p-value, we need to be able to find out that we need to reject or accept the null hypothesis. So if we calculate the p-value based on the actual z, then we can go to the conclusion and then interpret the result that we can accept or reject the null hypothesis. So actually what we're gonna do in here, I'm gonna summarize it. We do test some problem, and we can go to the conclusion and say either is statistically significant or not based on critical value and z statistic, which is calculated based on the sample mean and the standard deviation. And at this stage is not enough. You need to calculate the p-value to be able to say that you're gonna accept or reject null hypothesis. However, if at the beginning you accept the null hypothesis based on the critical value, then the situation is different. We're going to talk about this in the next lecture more in detail. Thank you very much for listening and hope see you soon.